Hey, ladies and gentlemen, this chapter, we are going to start talking about evolution. All right. So before going into the notes, no, this is not the notes. Before we get into the notes, uh, a lot of people every year get upset about evolution because they don't want to believe in it. They don't think that it's going to mesh well with their religious beliefs, and that's fine. All right. I am never going to ask you to ignore your religious beliefs for these scientific theories, right? That you do you on that. I am going to ask you, however, to pay attention, to listen to what I'm saying and understand what people believe about science, right? And the big thing, this is the biggest thing. I'm going to be providing you with actual facts, right? Not beliefs, but facts, right? Because theories, despite contrary belief about what this word means, it doesn't mean a belief. A theory is not a belief. A theory is a conclusion or an explanation based on factual evidence. All right. Real things that exist in real life that people have observed, have witnessed, have recorded, and have studied. Right? That's what we are going to be talking about, the evidence, the factual evidence that leads to the theories. All right. So let's break down some of the words. What we're going to be talking about today is the terminology that we're going to be using to avoid certain confusions. All right, get my thing working here. Here we go. All right, so our first term that we're going to be talking about is prediction. Right, a prediction is an educated guess. Right, that is the actual guess. I predict that this will happen. All right, so I got a guy dressed Superman on the top of this building, and I predict that if he were to jump off, he's going to get hurt. That's my prediction. I think if someone jumps from a high spot, they are going to get hurt. And that's all a prediction is, guessing what's going to happen. A hypothesis is also a guess, an educated guess at what causes that outcome. All right. An if then situation. If this person jumps, they will fall because of this. They will get hurt because of this. Right? I think they got hurt because the higher you fell, I think falling from a higher spot is going to cause more pain. It's going to increase your speed or something. That is a guess. I think jumping from a high spot causes more pain. That's your hypothesis. Notice that I didn't study anything. I didn't record anything. Right? I didn't even observe anything. I just took a guess. That's a hypothesis. And then based on that hypothesis, then I will begin my experiments. Right? And then during my experiments, during my observations, I would list principles, right? A set of laws for a certain situation. For instance, objects fall toward the center of mass. That is a principle, meaning it is a fact. No matter where you stand, oops, I thought I had something there going. No matter where you stand on this planet, this guy dropping the ball will always go toward the center of the center of the planet. If he's standing over here, then the ball would be going this way. If he's standing on the bottom of the planet, the ball would be going up. If things fall toward the center of the planet. Another fact, things speed up as they fall. Fact, right? The longer you are falling, the faster you're going to go until you reach something called terminal velocity. That just means the air resistance is keeping you from speeding up. But without air, you would just keep speeding up. Fact. Denser materials sink to the bottom, right? That is another fact of life, that if something is denser, it can sink farther, right? Those are all facts that people have studied, that people have observed about this. Right? The theory is going to be that these facts are all somehow connected. I theorize that if you jump off a high spot, fact, you will fall down toward the center of the earth, right, in that direction. You're not actually going to hit the center. but in the direction of the center of the Earth. You will speed up as you go. That is a fact. And the denser you are, the more you are going to resist air resistance and go even faster. Those are all facts. So the theory is something is causing all of that to happen. Something is causing these facts to exist. And notice that the theory doesn't say the same thing as the hypothesis. The hypothesis is that I think you got hurt because you jumped off someplace really high, and the height caused that. The theory is something causes these facts to connect together. Something causes these facts to exist. Right? In this case, that theory is gravity. Yes, gravity is still technically a theory. It's a very strongly recognized theory, based on a whole bunch of evidence, lots of evidence I didn't even talk about today. But the theory of gravity is that it's some kind of energy field around the planet that we can't actually detect. We can detect how it interacts with us, how it affects us, but we don't have any way of detecting the energy field itself. So we can't say that gravity factually is there. It's still a theory. But what it does to us, we cannot deny, because those are all facts that we use to come up with this theory. We cannot deny facts. So here's examples. Oh, sorry, I forgot about the slide. Facts and opinions. Facts, objectively true, cannot be disputed. And opinions are subjective, meaning they're opinions. They can be disputed. For instance, larger pupils help you see in the dark. That is a fact. As you go in the darker and darker rooms, your pupils will get bigger, and that's going to help you see things. The opinion is large pupils look weird. That's an opinion. Maybe I don't think they look weird. Maybe I think they look cool, right? But you cannot deny that larger pupils help you see in the dark better. That is a fact. So let's talk about these facts and how they help us come up with a theory. And the working theory is what we evolved from, not evolution's existence. Believe it or not, evolution's existence actually is a fact. We have observed evolution happening. In fact, we have observed it happening in local news, right? COVID-19, the coronavirus actually existed for an extremely long time, but everyone has gotten the coronavirus. Like, the coronavirus is just such a thing that we don't even really think about it. That's like not the common cold, but it's a cold. It's a respiratory disorder that everyone gets in their childhood. You get it just from going to school and being around people who have it. The virus evolved into a new form that we were not capable of handling. All right, so evolution is a thing. The theory is, did we evolve from anything? And if so, what? That's the theory. Because we can't actually observe our own past evolutions because we weren't there until it happened, until after it happened. Right. So taking a look at this tree, this is called an evolutionary tree. And looking at us, humans, and this species called A.R. ramidus, is actually an extinct species, doesn't exist anymore. That's what the dotted line is for. But we apparently have a shared ancestor. Again, that's theory. The evidence is skeletal evidence, fossil evidence, right? We have a whole bunch of skeletal similarities with them. And another big thing is they were bipedal. Based on the position of their hips, they could actually stand up straight, which is very weird when it comes to apes. All right, so theory is humans and A. ramidus had a shared ancestor. This creature right here is not a human or an A.R. ramidus. right? This is some other thing that we evolved from, where apes became bipedal, meaning they walk on two legs. Everything before that walked around on four legs. So this is the first one to walk on two legs, and that group split into two different directions and evolved differently. All right. So let's talk about hypothesis versus theory on this one. Because these guys died out, we want to know what caused them to die out. Hypothesis, the opposable toe, is the cause of them dying out. That's my guess. How do I know that opposable toe? Look at the bone structure here. Look at the picture based on the bone structure. Like just like we have opposable thumbs, and they had opposable thumbs, they also had opposable toes. Right? That's my hypothesis, is that the opposable toe is the reason why they died out. They went extinct. That is not a theory. That is not even a fact. I don't know why they died out. Here are some facts, though. Having opposable toes is not conducive to walking around on two legs. All right, it works well if you're walking on four legs. It works great if you're climbing in trees. Walking around on the ground on two legs, it's actually better to have straight toes, straight big toes, non-opposable. And there is tons of evidence of that. So we can't study these guys because they're extinct. We study the next best thing, chimpanzees. We observe the way they walk. Gorillas too, but it's easier to get closer to chimps. It's a bit safer. And we observe the way they walk, record their steps, record their patterns, and not only are their hips not good for bipedalism, but also their toes, the way they place it down causes them to have more of a side-to-side wobble, which slows them down, where having straight toes actually helps speed us up. So the hypothesis was they died out because of the opposable toe. The theory, based on the evidence, is that having the opposable toe slowed them down and was a selective force against them, meaning it prevented them from surviving, prevented them from competing with us, right? We were faster. So we got to the food better than they did. They were struggling because we were taking all the resources. And with the lack of resources, the theory is we out-resource them because of their toe. Do I know that's an absolute fact? No, I do not. I don't even know if it's an absolute fact that we're even related to them, but the evidence strongly suggests it. That's what makes it a theory. A hypothesis is a random guess. A theory is very strongly supported by evidence. That's the big difference. And that's what we're going to be talking about this chapter. All right. At this point, I'm done talking about those words. If you're curious about the rest of this map, I will go on, but otherwise you can just click this off. Have a nice day, guys. All right, continuing with this map, fossil evidence and DNA evidence, by the way, suggests that we are related to all of these guys, just further and further related, right? This shared ancestor also had their own shared ancestor with chimpanzees, right? A lot of people think that we evolved from chimps. People think that's what scientists think, and that is incorrect. There is absolutely no evidence to suggest that we evolved from chimpanzees. Right? No, I don't think any scientists have ever even claimed it. Those are probably just people who misunderstood what scientists said. What scientists suggest is chimpanzees and this shared ancestor that we had has their own shared ancestor. And then this group split into two different directions. Some of them learned to stand up on two legs and some of them did not. Chimpanzees, even though they can walk on two legs, do not prefer it. They're much better on four legs. They walk around on all fours. And then another connection, chimpanzees and gorillas. We're actually very far related to gorillas. We're much closer related to chimpanzees. In fact, check this out. We are about 98% genetically similar to chimps. You take a human DNA sample and a chimpanzee DNA sample, there is only a 2% difference. Some sources I've heard 97%, some sources I've heard 98%, and some I heard 99%, but that's still extremely similar, right? It's about 2% different. And that 2% is what gives us this extreme different look, right? Most of that 98% that's similar is going to be chemical. We have a lot of the same body chemistry going on. We have a lot of the same organs. We're very closely related. Gorillas are a little bit further than that, and some shared ancestor between this group and the gorillas. That shared ancestor happened to be the first group to climb out of the trees and walk around on land. That's what this word means, terrestrial quadrupedalism, meaning they walk on all fours on the ground. First group of apes to do that. Everyone else before that stayed up in the trees. So the gorilla shared ancestor and orangutans, or whatever they're related to, they would have their own tree going on over here we're ignoring. Their ancestors would have been staying up in the trees. And then orangutans and our shared ancestor over here, this whole big group shared ancestor would have a shared ancestor with something called a gibbon. Now, all these animals here do exist. By the way, you can see gibbons in the zoo. Orangutans and gibbons both hang out primarily in the trees. They can come down to the ground. They don't prefer it. But this shared ancestor flipped that rule, and fossil evidence suggests that they preferred being on the ground and only occasionally went in the trees. And then fossil evidence suggests, and actually genetic evidence really at this point suggests that we are very closely related to them. And then there's fossil evidence suggesting a extreme similarity to A.R. Ramidus and us. And they're the only ones who walk around on two legs. So that's all evidence, factual evidence, causing us to put the pieces together to create this theory. Right? And like I said in the very beginning of this, if you don't want to believe the theory, I'm not going to ask you to. All right? You believe what you are comfortable believing, but I am providing you facts, to the facts that these theories are based on. All right? So you do have an assignment today, not based on this video, but based on some brain pops. So go ahead, do those, and I will see you in the future. Have a nice day.